Thanks so much, Laura. And I've just loved how much nature has been centered here as we talk about systems change. And I'm going to continue that with our friends, the beaver. So how many of you have had an opportunity to watch beavers build a dam and turn a forest into a pond? Anyone? Well, they're ecosystem engineers that have sculpted land across North America. And growing up, I had the great privilege of watching a beaver family in action. And by watching and observing and learning from them, I saw that ecosystem disruption is not necessarily a bad thing. And in fact, it brings a lot of positives along with it. Over the course of my career, I've supported and funded and trained over 100 different early stage startups tackling some of the biggest issues we're facing today, from food insecurity to plastics pollution. And now, as the Director of Innovation at the Biomimicry Institute, I work with entrepreneurs that are learning from nature to tackle big systemic environmental toxicity and climate issues. Just like our beaver friends, they are disrupting industrial ecosystems to create a thriving and diverse economy. So to help paint the picture of what we do and how we work to create a world that looks and operates like nature, I want to share with you one lesson that I hope you all take away from this, a biology lesson that I wish was taught to me when I was studying to be an engineer. And that is that it's all about the flow of energy and nutrients. So energy enters the planetary system via the sun, primarily. That sun and water and carbon dioxide turns into new material, like the leaf we see here. A secondary consumer comes along, like our beaver friend, and eats that material. Eventually, that beaver might die, or the leaf might fall from the tree and start to decompose. Thank goodness for fungi and bacteria who help make that happen. And those nutrients are then distributed back into the environment. They dissipate back into the environment where they're waiting to be turned into something new. So that's the biology side. Here's what I was taught as an engineer and what many of you might know as a system. Energy enters into our system via an extracted resource, usually oil. We then use that oil to take material out of the ground, send it halfway around the world, process it, put a whole bunch of chemicals in it, heat it up to super hot temperatures, and then send it back to the stores where you and I might buy that. We use it for a few years and then throw it in the landfill. All along the way, that system leaks. We see that as pollution. That is quite different than the natural model. And the good news is there's some great progress happening in the circular economy space to move us from this linear model. But we'd like to help evolve that definition to really look at a fundamental law, the second law of thermodynamics, that states that all energies will dissipate energy, or to put another way, all systems will leak. So we do see this happen. I mentioned pollution. We see oil spills, we see trash on the side of the road, we see literal islands of plastics in our ocean. So that doesn't happen in natural environments, though. When a tree falls in the forest or when that beaver dam reaches its end of life, it breaks down into those basic building blocks of water and carbon dioxide and other nutrients that were used to make that. And those nutrients go throughout the environment, ready to be turned into something new. So here is the brief and bold idea and what brought me here today, and it's to explore what would our world look like if we adopted that model. How would our definition of the circular economy evolve if we looked at this, that all systems will leak? How will we change how we design and fund our world today? And to help illustrate that point, I have an example I'd like to share with you. 50% of microplastics found in the ocean come from paint. 50%. How we make paint today is similar to the story I told you. We usually extract resources from the ground, a mineral, a metal, or oil, to use it as a pigment or a dye. We mix it with a plastic acrylic binder, add in a solvent like water or oil, and then paint our buildings. over time and at the end of its life, the plastic breaks down and sheds out as a microplastic into the environment. So, putting on our Asking Nature hat, what would nature do? Let's look at one of the most brilliant organisms I know that doesn't do any of that and does not release microplastics, the peacock. These brilliant colors are caused by a phenomenon known as structural color. You can find out more if you search for that, but very quickly, there's a nanostructure kind of pattern that reflects wavelengths of light back to your eyes, and that's what we perceive as color. There's no pigments or dyes involved in this. This is an organic material, so at the end of its life, when that peacock or butterflies that exhibit the same trait break down, they turn back into basic building blocks, ready to be turned into something new by the environment all around us. Scientists from the University of Cambridge have been studying this, and they've found a way to create 100% cellulose-based paints and pigments. Cellulose is that same material that the beaver uses to make their dam. At the end of its life, this paint will break down and dissipate back into beneficial ingredients to be used and turned into something new. So we've supported 2 startups out of this lab, and they're both going on to disrupt this $200 billion paints and coatings industry. And I really love sharing this example because it makes us ask the question, what if we replace the source of microplastics from the very beginning? We don't have to worry about the cleanup, but what if we could actually replace that just by looking and asking for nature's help and guidance? So just like our beaver friends, who are ecosystem disruptors, and we believe that we can learn from nature to disrupt our industrial ecosystems. Millions of years of evolution have taken place that we can learn from, and from that learning, I truly believe that we can create a planet that not only is beneficial for humans, but for all species we share our home with. Thank you so much.